Think about the last time you played pool. You hit the white ball, it speeds across the green felt, then it slams into another ball. Energy transfers, the other ball moves. This is a collision. Our universe is full of collisions. They happen on a grand scale, with planets and stars, but they also happen right here on Earth. Think about a car crash or a bouncing basketball. Each impact tells a story of energy and motion. Physics helps us understand these stories. Two key concepts are impulse and momentum. Let's dive in. We experience these concepts every day. When you jump off a step, you don't instantly teleport down. You have downward momentum. A heavy truck speeding down the highway, it has a lot of momentum. A tiny pebble rolling down the same road, not so much. These are just glimpses into the fascinating world of physics. Join me as we explore the principles of impulse and momentum and their profound impact on our lives. Momentum is a way to describe how much oomph an object in motion has. Picture a train rolling down the tracks. That train has a lot of momentum because it's big and heavy and moving fast. Now picture a fly buzzing around. The fly has less momentum. Why? Because it's much lighter than the train, even if it's moving at the same speed. We calculate momentum with a simple equation. Momentum, P, equals mass, m times velocity, v. That's P equals m times v. Mass is how much matter is in an object. Velocity is its speed in a specific direction. So, momentum depends on both how heavy something is and how fast it's going. Think about a bowling ball and a tennis ball rolling towards you at the same speed. Which one would you rather stop? Probably the tennis ball, right? Even though they're going the same speed, the bowling ball has more mass. Therefore, it has more momentum. Momentum is a powerful concept that helps us understand the motion of everything from atoms to galaxies. Now let's talk about changing momentum. Imagine hitting a tennis ball with a racket. You apply a force to the ball for a short amount of time. This force changes the ball's momentum, making it move faster in a different direction. This change in momentum is called impulse. Impulse, J, is the force F, applied to an object multiplied by the time dt the force is applied. So, J equals F times dt. The bigger the force and the longer it's applied, the bigger the change in momentum. This means a bigger impulse. Think about hitting a golf ball. A golfer swings the club and applies a large force to the ball for a short amount of time. This results in a large impulse, sending the ball flying over a long distance. Impulse is all about changing the motion of an object. Whether it's a tennis ball, a golf ball, or even a rocket ship, impulse is the key to understanding how we manipulate motion in our universe. Section 4. The physics of a home run momentum in action. Let's break down a home run in baseball. A pitcher throws a fastball. The ball has momentum. The batter swings the bat, also with momentum. When the bat hits the ball, there's a loud crack. That's the sound of impulse. The bat applies a huge force to the ball in a fraction of a second. This force changes the ball's momentum, sending it soaring through the air. The greater the force of the swing and the longer the bat stays in contact with the ball, the greater the impulse. A larger impulse means a bigger change in momentum, and potentially, a longer home run. This example shows how we use impulse to our advantage in sports. By understanding these physics principles, athletes can optimize their movements to hit a ball farther, jump higher, or throw faster. It's all about harnessing the power of impulse and momentum. Section 5. From crash to safety, impulse in car design. Car crashes are unfortunate examples of impulse in action. When a car hits something, its momentum changes very quickly. This sudden change in momentum means a huge force is applied to the car and everyone inside. Car safety features are designed to manage this force and minimize injuries. Think about airbags. They inflate in a crash to increase the time it takes for a person's momentum to change. By extending the time of impact, the force is spread out, reducing the chance of serious injury. Crumple zones in the car's frame work similarly, absorbing some of the impact energy and extending the time it takes for the car to come to a stop. These safety features are all about manipulating impulse. By understanding the relationship between force, time, and change in momentum, engineers can design cars that better protect passengers in a crash. It's a testament to the power of physics in improving our everyday lives. Section 6. Taming impulse and momentum, from sports to spacecraft. The principles of impulse and momentum extend far beyond cars and sports. They're crucial in everything from designing safer helmets to building rockets that can escape Earth's gravity. Let's explore a few examples. Sports equipment, tennis rackets, golf clubs, and baseball bats are all designed to optimize impulse, allowing athletes to transfer more energy to the ball. The materials used and the design of these tools are carefully engineered to maximize performance. Rocket propulsion. Rockets work by expelling hot gas out of their engines. This expulsion creates thrust, a form of impulse that propels the rocket upward. The longer the engine fires and the faster the gas is expelled, the greater the change in the rocket's momentum. Impulse turbines. These turbines use a high-speed jet of fluid to turn a wheel, generating power. The fluid's momentum changes as it hits the blades of the turbine, transferring energy and creating rotational force. These are just a few examples of how understanding impulse and momentum allows us to design and build incredible technologies. From the equipment we use to the vehicles we ride into the spacecraft we send into the cosmos, these fundamental physics principles are at play. Section 7. Understanding the universe one collision at a time. Impulse and momentum are fundamental concepts in physics. They help us understand the motion of objects and how that motion changes due to forces. From the everyday collisions we see around us to the vast interactions of celestial bodies, these principles are at work shaping our universe. By studying impulse and momentum, we gain a deeper appreciation for the laws that govern the cosmos. We can design safer cars, build more efficient machines, and even explore the vastness of space. So the next time you witness a collision, take a moment to think about the fascinating interplay of forces, time, and motion at play. You'll be looking at the universe with a physicist's eye. Remember, physics isn't just about equations and formulas, it's about understanding the fundamental laws that govern our universe. And as we continue to explore and unravel these mysteries, we unlock new possibilities for innovation and progress. So keep asking questions, keep exploring, and never stop being curious about the world around you.